So that's just 3 lines of code, and our server is now secured for those kind of attacks. So if we try to execute this query, we will get an error. GraphQL servers first analyze the query before actually fetching all the data. So this will happen before we try to fetch everything. So we won't fetch millions of records. We just take a query, parse it. We figure out that the query is too deep, and then we get an error. Great. But what if we have 10,000 users and each one has 1,000 friends? So we have a query like that, 10,000 users, 1,000 friends, and we have 10 millions of elements just from the start. What can we do about that? Well, we can try to make the depth limit smaller, but then we wouldn't be able to fetch any friends for users, and it's no use to, well, it doesn't make sense to use GraphQL at that point. The main point of using GraphQL is the ability to have the flexibility to express any query we want, any reasonable query we want. So what else can we do about that? We can use pagination. How do we do that with GraphQL? First, before we start, we define new scalar type, which is also simple to do. You just need to grab a library that allows us to generate another number scalar type. And we define it as a pagination limit. We set the minimum and maximum page size. In our case, it's 5. Then we add the pagination in the schema. So whenever we fetch users or whenever we fetch friends, we would need some kind of arguments. And we will need, for example, if we use the pagination in the kind of limit offset pagination, so if on the backend we have like any SQL database, so we would use this pagination. So we define the page size and we define the page number, but we use the scalar type of pagination limit to make sure that it's validated and secure. Then, after adding the pagination in the schema, we need to handle the pagination in resolvers. So whenever we fetch users or we fetch friends, then all we need to do is pass those arguments to some kind of the layer that is below resolvers. So probably it would be a database layer or some kind of an abstraction that will do the pagination for us. So the good thing is that it's still not that great amount of the code. We just added, let's say, 20 lines of code. But right now, if we have like a nested queries and we have like a large number of records in our database, we still fetch like 10 users, 10 friends, 10 friends, and 10 friends, and we get 10,000 elements. So we can actually relax the depth limit, but we should never eliminate it, at least not with this, with those two validation rules. So setting up the pagination allows us to fetch only like a small portion of resources, and if we relax the depth limit, our queries can be more flexible, so we get more out of the GraphQL thanks to that. Okay, but what if one tries to exceed the page size? So let's say we try to fetch users, but we try to fetch set the page size to like 10,000 of elements. Fortunately, nothing happens. We're good because we set the scalar type that will do the validation for us. And it all happens before touching the database. So it all happens at the first stage when the server receives the GraphQL query and parses it and decides if the query is valid or not. In this case, it's not because the page size is too large. Okay, but what if One uses aliases, and this one is fun. Let's see how it works. So we fetch users and their friends, and that's the simple query. But then we add another alias for the same query. So we fetch maybe the same data or the data with different arguments, but let's say for the sake of simplicity, this exactly the same query. So we fetch another 10 users and 10 of their friends. And we then add another 10 users and another 10 friends. That's fine. But when we have a bit more of those aliases, and we add those 10 users and 10 friends, 10 users and 10 friends, we have quite a lot of them, and we get 100 millions of those elements. And this will probably crash most of your servers. If that doesn't scare you yet, think about that. Aliases allow another kind of attack, the brute force attack. So consider another part of our schema. This time we have a mutation, and this a lot of mutations, and those mutations are used to handle the authentication logic. So we can log in, we can request password reset token. When we get the token, we can change the password. And okay, it works. It's behavior that we are probably familiar with. We all reset our passwords. So let's see how the normal use case of this kind of query looks like. So I try to log in, but I don't remember my password. I'm Bob at example.com, and I use my most secure password that I use pretty much in every other service. So I try to log in, and I get the what I expect is to get instance of current user. So the user record that is authenticated, but in this case, I'm not logged in, I get null. All right, so I ask for the reset token. So I pass my email, bob@example.com, and I get true. And in fact, I will always get true here because our system tries to be smart and tries to hide the fact. It tries to not reveal which emails are inside of the system and which are not. What happens in the background that we are either receive the special reset token on our email or not. In this case, my email exists in the system and I receive an email. Dear Bob, change your password using this secret and secure token, BAB. So this is the token. And then I use another mutation, change password. I pass the token, BAB. I pass my email, bob@example.com, and I pass my super secure new password. And this operation succeeds. So finally, I can log in. I pass my credentials, and I get the data of the currently authenticated user. It works. Nice. The question now, is it safe? What do you think? Is it or not? Of course it's safe. You can't change password without an email and token, right? Okay, but what if I have an email and I can guess the token? Let's see how hard is that in GraphQL. So you can imagine, in REST API, you could try to enumerate all those tokens, make a lot of different requests, and finally, you might break in. In GraphQL, you can use aliases, and you can enumerate all possible tokens and try to guess. So I execute one single query, and those are responses of those queries. If I execute mutation on the GraphQL server, mutations, queries happen in parallel, mutations happen sequentially. So it will execute every of those change password mutations with different tokens, the same emails, and the same passwords. And let's see what we get in response. One of those mutations succeeded. And that's enough for us to break in. Right now, as soon as one of those operations succeeded, the password of Bob is changed. And Bob lost access to the account, and the hacker got the access. So right now, the second step is to just log in. And we could probably add this login mutation to the previous request. So it would actually be just one GraphQL document passed in one HTTP request, and it would break in, it would change the password and break in immediately. So that's kind of scary. And what can we do about that? Well, first of all, you need to generate safer tokens, not tokens I showed you in the previous slides. So this is the actual code that was used to generate this unsafe token. So you can see in the name of the function that it shouldn't be used in production, because it just takes the dictionary of 3 letters and it basically randomizes them, and that's the secure token. This is not the way to generate tokens. If you want to do it properly, you should use some cryptographic library and use some better algorithm to do that, and make the dictionary larger, make the actual token longer, and use proper cryptographic algorithms. But this is something that you need to do regardless if you use GraphQL or REST API or other APIs. You always need to generate safer tokens than this. In GraphQL, you need to do one thing. You need to make the brute force harder. How to do that? Well, you can use a tool called query cost analysis. It's also implemented as a library. You can also create it on your own. It's basically parsing the query again, but assigning some cost to any query or any mutation. So this kind of library, GraphQL cost analysis, allows you to specify some cost. And so we need to define it. And at the beginning, we don't need to think about what this number means. We can assign an arbitrary number, and then we need to figure out what the cost of any part of our query or any part of our mutation needs to be. And we don't need to calculate that, actually. We can do it by filling it. You'll see that. So to implement that, we need to add a validation rule using this library. So we create the validation rule, we specify maximum cost. We can specify the default cost. If we don't specify it, every query and every mutation will have a cost of 0, and we will need to override it in code. So I suggest you specify some kind of default cost. It can be 1, it can be 10. You can change it later, but start with something. It's better to assign some cost to any part of your query and then maybe override it to 0, than to do it other way around. And what I suggest you to do is to set the onComplete event handler. So every time this query cost analysis tool runs, it will tell us the actual query cost. So other thing we need to do is to define in our schema the cost directive, which will allow us to modify the cost of each part of our query. And let's see how to do that. If we have the pagination in some kind of a query, so usually every part of the query would cost just 1 point, this abstract point that we defined before. But when we fetch users, ideally, it would be ideal if we could assign exact cost for exact number of users that are fetched. So we can make it so with this tool using the cost directive. So we specify that the user's query should be modified by something, should be the cost of this query should be multiplied by something, and we specify the multipliers. So when we ask for users, we either specify page size or we keep it as default, but the page size determines how many of those users we can fetch. So if we add a page size to the multipliers list in the cost directive, then the default complexity of 1 will be multiplied by the number of actual records that will be fetched by the pagination. And we need to do that for every part of the query that returns a list of records. The other thing we can do is to override the default cost of some part of the query or some part of the mutation. For example, when we fetch a user, it's not really dangerous to fetch 2 users, to fetch 5 users. Maybe if we fetch millions of users, then we can crash the server. So we need to multiply them by the number of actual users fetched. But some of those operations can be really dangerous, as we've seen before, and we don't want to allow them to be executed many times during one request. So we just need to assign high enough complexity to the mutation and not allow user to execute like 2 of those mutations, but maybe we could allow him or her to execute 1 mutation that is dangerous and maybe fetch 200 of users. So let's assign a complexity that is greater than, let's say, the half of the maximum size, so we cannot request 2 password tokens at one time, but it's less than maximum complexity, so we can do something else while doing this mutation. Because then, if we don't do that, if we assign the maximum cost, we lose the flexibility that GraphQL gives us. So we assigned an arbitrary complexity of 750, and we can change that later. So if we fetch users and their names, the query cost analysis reports that this particular query costs 11 points. Okay, that's fine. If we pass this query, so users and other users, so this query cost is 22. That makes sense. 1 of those queries costs 11, 2 of those queries cost twice this much. Okay. If we have users that have friends and their names, well, this time this query cost is kind of weird because it's not multiplying everything. It's kind of like multiplying everything. We have 10 friends, we have 10 users, we have 10 friends, but the algorithm works in a different way, so it adds some other stuff. Probably it adds the execution of the whole query to the equation. But the good thing about that is we don't need to go into details of this algorithm, because we need to just figure out what kind of queries we actually run and figure out if they are allowed to if they fit in our budget for query, or if they don't. If our normal use cases fit within a budget, we are fine. And if some kind of the dangerous queries or queries that can DDoS our system fit in the budget, then we need to figure something out. So it's not that important to look into the actual algorithm. We can just figure out what different kinds of queries cost, and then figure out if we need to change something or tweak something and see what happens. So if we pass this kind of query, this one costs 1,113 points. So it's more than 1,000. So this query automatically returns an exception. So that's great. The other kind of query, we want to change the password. We can do it once. This query costs 750 points and it fits within the budget, so everything is okay. But if we try to brute force it, the cost of this query is like 20,000 something. So this one exceeds the budget multiple times. So we are safe. Great. Okay, but what if? What if one tries to execute multiple queries? Well, if one tries to do that, then we are in the same position as any other API programmer. If you use REST API, you have the same problem. If you have GraphQL and you have this problem, well, that's fine. But we need to handle it somehow. Usually we need to rate limit somehow the query. So we need to find out, identify users and allow users to make at most, I don't know, 5 requests per second or 100 requests per minute, whatever the rate limit is, but we need to limit requests somehow. We can do it either at the HTTP server level, so the same way as we would do it in the REST API server, but in GraphQL, we can also make it more precise. We can do it at the GraphQL server and rate limit only specific parts of the query. How to do that? We just need to add the rate limit directive. So again, we install some library, then we add a bit of code to the context that will identify users. So we assume that we have a public API, so anybody can use it. In this case, we need to identify users, so we need to probably fetch their real IP and attach it to some kind of a record within the context. And then we need to configure the rate limit directive by fetching the identifying data from the context and passing it to the library. If we do that, and if we define the rate limit directive in the schema, the actual implementation is provided by the library, but we always need to define it within the schema. We can use it in the following way. So we define the window that is expressed in time, like within 5 seconds. We can execute at most 1 change password mutation. And we can do that for any query or any mutation. So if somebody fetches users and we are sure that our server can handle that because we pay a lot of money for servers and we are sure that they will handle the traffic, we don't need to rate limit them. Or we can rely on rate limiting at the HTTP server level. But for things that are expensive or things that are dangerous, we can specify a directive and make it rate limited. So this is how it works. I tried to change my password, and for the first time it succeeds, but then I tried it 2 seconds later and I get an error. You are trying to access change password mutation too often. Great. So that gives us more flexibility than in the REST API. And that's enough. That's enough to make GraphQL as secure as REST. Probably some security experts will fight me on this, but this is enough to start to be brave and start to use GraphQL for the public API, and not only for private implementation to fetch the data between some kind of web services that exist only on our internal network and keep the GraphQL only for communication within them. Right now, using those simple tools, you can use GraphQL to make the public API, and be relatively secure and relatively confident that nobody will hack your API. So first you need to do is limit def, paginate data, limit rate of either requests or specific queries or mutations, and optionally analyze cost. Why optionally? Because if you use the first three of them, maybe this will be enough for your use case. Maybe if you use analyze cost and rate limit and pagination, you don't need to limit def, and analyzing cost will be enough for you. So anyway, you can use those 4 simple tools, which can be configured in like less than 100 lines of code, and make your GraphQL server secure enough to make it public. One more thing. If you are serious about security, you need to monitor your traffic. And this is like the topic for totally different presentation. But you need to analyze the traffic, and you need to know who, when, and how attacks you, and then you can react accordingly. If you need more resources, I suggest you go to the OWSAP and find the GraphQL cheat sheet. This is just one website that enumerates all different attack vectors that are quite common in GraphQL and different ways to handle them. If you want to know more about hacking GraphQL from the point of view of a person that is not necessarily a programmer that implements the API, but a hacker or pen tester that knows nothing about the server and tries to hack it with standard tools, I suggest you to watch the Hacking GraphQL presentation. It's in Polish by Maciej Kofel. The presentation was given during the React.js and GraphQL Festival, which was a conference in Polish. All recordings are still available, and you can use meet.js code to get a 20% discount if you want them. If you don't know GraphQL enough, if that presentation was too hard, or if you didn't understand what to do, one level before, if you are not ready to make your GraphQL server public, I can teach you how to make a GraphQL server. In 7 weeks, if you're interested in that, the next edition of the online course will start soon. And you will find all the links in the all the resources in the link I previously mentioned, graphql.pl/meet.js. And if you have any questions, I'm happy to answer them right now.
Yes, exactly. That's really amazing occasion to ask questions to our speaker, as we have one speaker right now. So everyone who is connected, please type your questions in the comment. I know that there is some delay between our presentation and YouTube, so just type it down and I will catch them. We have a very small audience here in the office.
Small but safe.
Exactly, but we are very safe here. It's not a crowded place. On last steering meeting, there was just one additional person. Right now we have 2. So I would say, from my perspective, it's really nice that you describe those GraphQL server stuff, not in relation to only Apollo server, which is the most popular one, but we can also use those strategies for Elixir GraphQL server, like Absent, yeah, and the other one. But how do you compare it? Do you think that enforcing those strategies in different GraphQL server could be easier or harder? Have you compared the Apollo server, for example, with Absent?
So it depends if the target language, well, it depends on the community that creates libraries for your target language. If you live in the Elixir world and you use absent library, then you need to find a library for rate limiting, for cost analysis, for pagination or defining scalar values, or it actually might be really easy to do in Elixir without any libraries. But all of those tools provide either validation rules or directives that modify queries. So if you have a library like that, it's not really that hard, because you need to plug it into configuration of your server. Basically, in most of the servers, there is a way to configure validation rules, and it's as simple as in Apollo. In this case, you just add a list of every validation rules that you need to add, that you want to add to your server. So basically, you get a library or create a simple validation rule on your own and plug it in to the GraphQL server. In case if you don't have like mature enough community, or you don't like the libraries that are provided by your community, some of those validations are quite simple. So depth limit, it's really easy to do on your own, because validation rules are implemented by looking at the parsed syntax tree of the query. So you get a structure which looks like a tree, and all you need to do is count branches. Well, not branches, count nodes that are not leaves, and you get the depth of the query. So this is as simple as finding the height of the tree, and you get the answer. And GraphQL server will give you the parsed abstract syntax tree that represents your query in probably any language, because it's a part of the standard. So actually doing those kinds of validation rules, it's not that hard, but most likely somebody already created it for you. So you just need to pick one and plug it into your server, and it's easy.
Yeah, so nice. It's somehow more scientific than just REST APIs. Right now, I will move to another room to prepare the streaming for the second part for this meeting. It will be a little musical concert. I will then move forward to the questions from the chat. But maybe there is a moment to some question from the audience. So I will just leave it for a moment.
So maybe first question from So I have a question. What do you think about the future of GraphQL? I mean, does GraphQL replace the REST APIs, or?
I'm hopeful for GraphQL. I'm not sure. Probably it won't replace REST API, because REST API is fine for a lot of use cases. For example, it's more secure than GraphQL at the start. Yeah. So all those things that we did here, like install in 100 lines of code some plugins to secure GraphQL, we don't need to do that in most APIs. And we can just start doing that. What GraphQL gives us is just an abstraction layer that it makes it easier to specify the domain language of our application. So in REST API, you think about resources and you think about URLs. Resources and HTTP verbs. And usually what's easy to do in REST API is to make a CRUD application. So create with posts, delete with deletes, and update with patch or put. But what about, for example, we implement a library and we need to borrow a book. How do we implement that? Do we create another resource that represents a piece of paper that we write the book, name of the book and the name of the owner, and we create this resource with post and delete this resource with delete? Or do we modify the book record? And it's kind of awkward in REST API. And in GraphQL, it looks like just execution of a normal function. So that's what mutations are. So I see it as it might become more popular in applications that are that want to express more domain knowledge or domain API, domain language of the application within the API. So I'm hopeful for that, because like if more people will try to do public GraphQL APIs, it will become more popular, because right now GraphQL is perfect for doing some internal APIs, because then you don't need to actually care about security if only backends communicate with using this GraphQL, or only trusted clients communicate with GraphQL. We can do other techniques, like we can cache, like we can make an allow list of all known GraphQL queries that are allowed for clients, and then it's easier.
Okay, thanks a lot.
Any other questions?
No, actually no. So
Great, let's go for a concert, I hope.
Wait one second. First, then of course there is an obvious question about materials. Yes, they all will be posted
Stop
to
streaming.
GraphQL.
Okay, so
PL.
everyone, remember, just go to the link graphql.pl/meet.js, and you will find all resources there.
Exactly. Thank you very much. Oh, I see some other people joining, so that's really cool. And also, don't hesitate to take a look at the tutorials from Michał. They're really awesome. He's also creating a great community around that. So it's not only he giving his expertise, but also other people that are learning, and you can learn together with them. Oh, I see somebody's writing. Next question. Okay, is it still another 15 minutes to start, right? Okay, no, we'll start right away. So just wait a moment. Let's welcome follow reverse. Let's plug off the
was. Maybe the bad times, maybe the sorrow will stay where it was. Maybe the bad times, maybe the sorrow will stay with us. Maybe the bad times. Maybe the bad times. Maybe they were gone with us. Maybe they were gone with us. Friends are gone sometimes, are gone sometimes. All friends are gone sometimes, are gone sometimes. The sound of the night, the only thing I see is the light, 100 meters far away. And it's enough, and it's enough, and it's enough, and it's enough, yeah. Watch the rain, and I got in my heart, I got in my heart, and it's now. The sound of the night, the only thing I see is the light. Only matters it's next song will be in Polish. Yes or no? Okay. Lecą dni, lecą miesiące, nie spodziewałeś się, że z twego życia zniknie słońce. Ono zejdzie na nowo, tylko trochę róż róż co było. Dla mnie ważne jest, że idę, choć my razem będzie miło. Choć my razem będzie miło. Na góry spójrz, znajdź myśl tysiąca słów. Znajdź myśl tysiąca
Nie zmienisz tego, co było. Dla mnie ważne jest, gdzie idę, choć my razem będzie miło.
Marcus, you want to say something?
Like you say?
Mm-hmm.
Okay.
Okay. Next song will be in English, and it's about emotions and how we can
Combine. Process.
yes. Thank you. Your love never fails. It never fades. Everything that happened. Your little heart you will be good for don't hold you back. I'm with you. Don't try. I wanna be like you, having emotion, but true. With all my heart and soul and my mind, I always got good. I wanna be like you, having emotion, but true. With all my heart and soul and my mind, I always got good. my emotions, I'm sure. With all my heart and soul and my mind, I'll always love you. This is our last song, or no? Yes? Yes? Yes. In Polish. And if you like our music, you can listen us on Spotify or YouTube. We are Follow Rivers. Yeah, so tak wiele. Każda chwila tak będzie, już nie mało stać. I tak tylko ja nie chcę być tu, czy zaraz. I nagle widzę uśmiech twój, chciany głos przytulam znów. Zatrzymam się na moment i hej, ile mamy już? Wiesz, tak naprawdę jesteś mój głos, słyszysz mi. Nic mi znów nie wychodzi, lepszej muszę być. Jesteś tutaj potrzebny i dasz taki znak. Zostaw jutro na później i chodź zaraz. I nagle widzę uśmiech twój, chciany głos przytulam znów. Zatrzymam się na moment i hej, ile mamy już?
martw się, co jutro ci przyniesie. Możesz zostać ze mną tu. Proszę nie goń za tym, co tak biegnie. Możesz zostać ze mną tu. Nie martw się, co jutro ci przyniesie. Możesz zostać ze mną tu. Proszę nie goń za tym, co tak biegnie. Możesz zostać ze mną tu. Tak wiele mamy już.
Thank you very much. Thank you for joining us here. It's really sad that we cannot organize that big meetings as it was in the past, the big audience. But there are some workarounds. Maybe next time we can meet in, I don't know, cinema or something to have larger space. Also, really, I'm learning how to organize everything here, like streaming. I know that there was a little delay before sound came in and also the video on YouTube, but we'll continue. Let's see how it goes. And thank you very much, everybody. Thank you very much, Michał. Thank you very much, Follow Rivers, and thank you very much for the audience. See you next time, and next month we're planning to have a special event in Poznań, possibly. When everything will be confirmed, I will let you informed on Facebook, LinkedIn, and at meetup.com. So see you there. Bye-bye.
Bye.